Alright, let's look at the practice exam 2, problem number 12. Alright, so we want to find the average value of this function of two variables over a triangle region whose vertices are 0, 0, 0, 5, and 5, 5. Alright, so let's sketch the triangular region first. So it's going to look like this. Alright, here is the y-axis. And here is the x-axis. Alright, and so 0, 0 is right here. So that's the origin. Right, and 0, 5. So x is 0, y is 5. So here, probably around there. Right, I'm gonna say here is 5. Alright, and 5, 5 is going to be up here, right? Where this is 5 right here. Alright. Then the y coordinate is also 5, so I'm going to just draw a triangle. Right, so it's going to look like that. Alright, so this is the triangular region. Alright, since area is fairly easy to find, so let's go ahead and find the area. So area is, this is a triangular region, so it's going to be 1/2. Base is 5 and height is 5, so 1/2 5 times 5, right? So this is 25 over 2. Alright, then we have to do a double integral. So double integral over this region, triangular region. Right, function is e to the x plus y. Alright, so let's do it with respect to x first. Then we'll do with respect to y second. Alright, so I'm going to fix y. So maybe I'll use a different color. Alright, fix y here. Then look, you can see that the x goes from 0, x equals 0. To this is a straight line, y equals x, or x equals y, so x equals y, right? So x goes from 0 to y, right? So once you've done that, we can start from, y is going to start from 0, which is going to cover that, and you keep on doing this until ... you can kind of swipe the whole entire triangular region. So you can see that the y is going to start from 0 and ends at 5. Right? So it's going to be 0 to 5. Alright, so let's evaluate this. So this is going to be equal to, let's see, I'm going to go here. Right, I'm going to leave the outer integral as it is. Alright, so if you take the antiderivative of this guy with respect to x, you will get e to the x plus y. Right, it really doesn't change. So then you're going from 0 to y. Right, so and then you have a dy. Right, so remember that these are x values, so we plug it into x. Right, so we have integral from 0 to 5. Right, if you're plugging y, so you have e to the y plus y, so e to the 2y. Right, minus if you plug in 0, so that would be e to the y. Right, then antiderivative with respect to y. Right, if you take the antiderivative of e to the 2y, you're going to get e to the 2y over 2. minus e to the y is e to the y. Right, then you're going from 0 to 5. Right, so those are y values. Right, so I'm going to go up here. Right, so this is going to be, right, plug in 5, so you have e to the 10. Then you have a over 2. Right, minus e to the 5. Right, minus, right, then you have e to the 0 is 1, so it's 1/2, minus e to the 0 is 1. Alright, so you're going to have, let's say it's going to be negative 1/2 plus 1/2 there, so it seems like there's 1/2, so I'm going to factor out the 1/2, and you will get e to the 10 minus, if you factor that out, 2 times e to the 5, and this is plus 1/2, so it's going to be plus 1, right? And we can actually factor this out, so I'm going to go ahead and factor this out. So this is going to be 1/2 e to the 5 minus 1 squared. Alright, so that's the integral. So if you want to find the average, right, remember that all you have to do is find the integral. So it's a 1/2 and e to the 5th minus 1 squared. Then divide the double integral by the area of the region. So 25 over 2. Right? Then we can just multiply top and bottom by 2. So 1/2 cancel out. So therefore, we can get e to the 5th minus 1 quantity squared over 25. Right? That's it. This is the average value. Right? I hope that this was clear.